Welcome, pre-algebra students. Today we're going to talk about probability. This is probability part 1. So the study of probability is the study of outcomes that have an equal chance of occurring. Say, for instance, things like flipping a coin or rolling a dice, things that you really don't have any kind of a power over. And that's given that the coin you're flipping is not weighted. It's a fair coin, and that's given that the dice are not weighted, that it's a fair coin. That's given that whatever spinner you're spinning is just a plain, ordinary, fair spinner. So the way that we write the formula for probability, probability is capital P, by the way. We say that the probability is equal to the desired outcome over the total possible outcomes. Okay? So the desired outcome, or the outcome that we want, over the total possible outcomes. So for instance, if we were to flip a coin and we wanted it to land on heads, we would write the problem like this. We would say the probability that the coin will land on heads. First, we need to write the denominator, the total possible outcomes. Well, the total possible outcomes for a coin is either going to be heads or tails. So there are two possible outcomes. So we'd write 2 right down here. Now, the desired outcome, or the outcome that we want, is heads. So that's only 1 out of the 2. This is the probability of a coin being tossed landing on heads. It's a 1 out of 2. That can also be called a 50% chance. You can put that into a percentage, and it's just fine. The face of a spinner, let's look at a spinner. I'm going to erase this bit here. We'll talk about a spinner. The face of a spinner is, it has 4 spaces. 1, 2, 3, 4. It has 4 numbers on it, and it is a normal, fair spinner. And I'm just putting this arrow somewhere. This is the spinner point. It's divided into 4 equal parts. If the spinner is spun many times, it should stop on each of the spaces an equal number of times. We can't dictate where that spinner lands as long as the spinner is even and it doesn't have any marks or indentations. It's just a fair spinner. Then it should land as many times on 1 as it does on 4, as it does on 2, as it does on 3. So if I wanted to say that I wanted it to land on 4, I would write my probability problem like this. I'd say the probability that the spinner lands on 4 is equal to, and the total possible outcomes that we have here is 1, 2, 3, 4. There's 4 spaces it could land on. So the possibility, or the total possible outcomes, is 4. The chances that it will land on the number 4, it's a 1 out of 4 chance. It's one of these spaces. So it's a 1 out of 4 chance. That is my probability. So I have a 25%, or a 1 out of 4 chance that it will land on 4. That is the same probability for it to land on 3. You have a 1 out of 4 chance for it to land on 3. You have a 1 out of 4 chance for it to land on 2. And you have a 1 out of 4 chance for it to land on 1. Because they are 4 evenly divided spaces, it is a fair spinner, and the likelihood of it landing on any one of those spaces is the same. Okay? All right, so let's look at dice for just a minute. Let me erase this. A single dice has 6 faces, right? So we have 1 dot, we have 2 dots, one side has 3 dots, one side is going to have 4 dots, the other side is going to have 5 dots, and then the final side has 6 dots, right? So those are all the sides on a little dice, which is also a little cube. So if I said that I wanted to find out the probability of whether or not my dice that I'm rolling would land on a number greater than 4, I'd write that like this. The probability that the roll of this dice will be greater than 4 equals, I have to write the total possible outcomes on the bottom. I have 1, 2, 3, 4, 5, 6 possible outcomes. And the ones that are greater than 4 are 5 and 6. So I have 2 possible outcomes that are greater than 4. So I'd write 2 out of 6. Now, in mathematics, especially in algebra, if you can reduce a fraction, you should do so. This is reducible or simplifiable. We can reduce it to 1 over 3, 1/3. We divided the 2 by 2 and the 6 by 2, and this is an equivalent fraction of 1/3. So the probability of getting a number when I roll this dice that is greater than 4 is a 2 out of 6 or a 1 out of 3 chance. I have a 33% chance of getting a number greater than 4. All right. So let's do a problem based on probability. All right, so in problem 112.1, a deck of cards contains 52 cards. 13 are spades, 13 are hearts, 13 are diamonds, and 13 are clubs. Jimmy tears up the ace of spades, shuffles the cards, and then draws one. What is the probability that the card is a spade? So let's look at this. We had 13 spades. That kind of looks like a little upside down shovel or heart with a handle, something like that. We had 13 hearts. We had 13 diamonds. And we have 13 clubs. And that looks kind of like that. Almost like a 4-leaf clover, but not really. There we go. It's a little bit better. All right. So we had a total of 52. But then he took one of the spades, the ace, and he tore it up. So now we have 12 spades. And that changes the total from 52 to 51 cards. So now the probability that we will have a spade, if I can actually draw a spade, is going to be, we have a total of 51 cards, and there are only 12 spades in the deck now. So our probability that the card he drew was a spade is 12 out of 51. Now we can reduce this by dividing both sides by 3, or the numerator and denominator by 3, and this divided by 3 is 4. This divided by 3 is 17. So there's a 4 out of 17 chance that the card drawn will be a spade. So let's look at another problem. All right, in this problem we're dealing with 2 die. So or 2 dice. Individually they're called a die, but we have 2 dice and we are rolling both of them. One is red and one is green. So what is the probability of the total when we roll them being 7 or being 4? So let's look at that. So here I've drawn an illustration of what it would look like for each of these possible outcomes of rolling 2 dice. So if I roll the red dice and it lands on 1, if the green dice landed on 1, we would have a total of 2. If the green dice was 2, we'd have a total of 3. If the green dice was 3, we'd have a total of 4, and so on. So the most we could get if the red die landed on 1 would be a 7 if the green die landed on 6. So you could see how I've mapped this out. If the red dice landed on 2, this is the answer for what it would be if the other dice landed on 1. If the green dice landed on 2, if the green dice landed on 3, 4, 5, and 6, and so forth and so on. So you can see I've mapped it all the way out to where if the red dice landed on 6 and the green dice landed on 6, the total would be 12, because 6 plus 6 is 12. So now, the way that we find the total number of outcomes when we have two numbers or two items is we multiply. We multiply the total number of outcomes for the first item, total outcomes of number 1, times the total outcomes of number 2. We have 6 outcomes for die number 1. I'm actually going to go ahead and do that in its color. Dice number 1 is 6 outcomes. 1, 2, 3, 4, 5, 6. And we pair that, or we multiply that, times the total number of outcomes for the green dice. And the total number of outcomes for the green dice is 1, 2, 3, 4, 5, 6. So 6 times 6 is equal to 36. And if you don't trust that, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So this proves true. The total number of outcomes for the first object times the total number of outcomes for the second object gives you the total number of outcomes for both objects when used together. So this is the number we're going to use as our denominator, because that's the total number of outcomes when using 2 dice. So now we can look at the probability of our total being 7. So I'm going to use this highlighter here. So if the total is 7, we're going to highlight that first. So 1, 2, 3, 4, 5. There are 6 possible outcomes where that dice could equal to 7. If the red dice was on 6 and the green dice was on 1, if the red dice was on 5 and the green dice was on 2, if the red dice was on 4 and the green dice was on 3, if the red dice was on 3 and the green dice was on 4, if the red dice was on 2 and the green dice was on 5, and if the red dice was on 1 and the green one was on 6. Those are our 6 possible outcomes. So that tells us that our probability for it equaling 7 is going to be, out of 36 possible outcomes, there are 6 opportunities for that to happen. And if we reduce this fraction, we divide the top and the bottom by 6, we get 1 out of 6 is the probability. All right, so let's look at the probability for our answer being 4 when we roll both dice. I'm going to use the highlighter again. I'm going to change the color a little bit. So if it is the possibility of being 4, or the probability of it being 4, we have 1, 2, 3 opportunities for it to be 4. If the red dice is 3 and the green dice is 1, if the red dice is 2 and the green dice is 2, and if the red dice is 1 and the green dice is 3. Those are our 3 and the only 3 opportunities that we have for rolling 2 dice and getting a total of 4. So we have, out of 36 possibilities, we only have 3 chances for the 2 dice to total 4. So if we reduce that by dividing the top and the bottom by 3, we get 1 out of 12 as our probability that it would be 4. And that is all we have for lesson 112. I would take this little chart right here and I would write it in the back of your notebook, simply because we are going to be answering more probability questions, and you're going to be using this probability table all the way through Algebra 2. So keep it handy, make a reference page, and you won't have to redo it every time we do one of these problems. And we will be doing more. All right, I will see you all in lesson 113.